Good afternoon. Thank you, ladies and gentlemen, to come here. We are going to try to introduce this topic, hot topic nowadays, for shipping. So it's my pleasure to be here in this nice environment. It's my first time in doing so. Okay, we are going to talk about this LNG as fuel, but first of all, in the first part of the presentation, I would like to introduce main drivers which we understand are leading the shipping community to use alternative fuels or like LNG. So we know that shipping is very traditional, but is the most efficient way of transportation. But even how the transportation by ship is polluting the atmosphere, and we know that there are tons of NOx and SOx and particulates. IMO has been involved in following this matter of the emissions to the air since the beginning, since 1997. And then in 2008, the rules for air pollution become in effect in MARPOL. They are continuously monitoring the situation, and this year even they have decided to make a third report, because this is the result of the second report they made about shipping emissions from shipping in 2007. This year in the Environmental Committee in March, they have decided to make another report, will be the third, and they are also following very close the evolution of the sulfur content in the fuels. The regulations now for air emissions as follows. You can see in this slide, as you know, the MARPOL regulations are the main regulations for NOx, SOx, sulfur and nitrogen pollution substances to the air. And inside the MARPOL, Annex 6, there are all regulations related to these pollution products and to the emission control areas. I will show you also another slide, details of all the emission control areas mentioned and included in the MARPOL. And last but not least, there are also regulations in the same Annex 6 related to energy efficiency and in close connection with CO2, greenhouse gases. On the other side, we have the European rules, European Union rules, which are very close to the International Maritime Organization MARPOL rules, and in line with this, in the last regulation in last year, that one. But almost more stringent in some aspects, in ports and passenger ships levels. I will show you later also the levels required for that. There are no regulations for international shipping or coastal shipping as far as NOx, but there are some regulations for inland navigation. And last, USA regulation, also specifically in California. We have regulations to comply with in 24 miles in the coastal area of the California state in the United States. These are the areas now defined as emission control areas. For the time being, we have the Baltic, as you know, the Baltic SECA, only for sulfur emissions. We have the North Sea, also SECA, sulfur emissions. We have the IMO Europe emission control area in United States and Canada, 200 miles far from the shore, for NOx, SOx, and particulate matters. So this is NOx and SOx, and that ones are also only for sulfur. The California regulations, 24 miles far from the coast, also related only to sulfur. And these charts, you can see the different dates of definition of the area and the entering into force of the stringent levels. 3 areas has entered already into force in effectiveness. The last one last year in August, North America and Canada, and the next one will be 1st January next year. will be the Caribbean US islands. So what is now required according to IMO and to California and European community rules is in this chart. We have the dates for the compliance with a certain limit of sulfur, in this case. Sulfur content in the fuels for use for shipping, for fuel in ships. The global IMO will become very, very stringent in 2020, 0.5. This is subject to a feasibility study in 2018. So depending on the status of the fuels available for shipping, the IMO will decide that this figure will be mandatory or not. The IMO in the emission control areas, that is becoming very, very stringent in 2015, so in less than 1.5 years from now, 0.1. Specifically, European regulations for passenger ships not sailing in emission control areas, but sailing very often between ports in the European Union, which is 1.5. European Union ports, so the ships in ports belonging to the European Union, they have to comply with 0.1, which will be the level here in the emission control areas. And in California, these levels are entering in the 1st January 2014. So what is the problem here? Well, the problem here is very simple. We have now fuels with sulfur contents around 2.4, let's say. This is enough for IMO, but it's not enough for ECAS areas, and will be not enough for that areas. Not for that, not for that. We need to find fuels with less content of sulfur, so more expensive. We have to go to use gas oil, diesel oil, distillate with expensive cost. MARPOL rules for NOx, you know, there are some different levels of compliance. Now we are in tier 3, in tier 2, sorry. Tier 3 level is expected, but subject to the approval of one draft in the next MEPC next year. This level, tier 3, could be probably delayed 5 years. So it means that the tier 3 levels probably will be mandatory, but in 2021, not in 2016. But we will see. This is subject to final adoption agreement in the next committee, environmental committee inside the IMO. But here, the problem with the tier 3 is as simple as that the tier 3 requires a reduction of almost around 80% of the NOx levels compared with the tier 1. And tier 2 is simple to achieve this 20% reduction in NOx, but to achieve the 80% reduction is very hard, very difficult for the engine manufacturers. Last regulations in the MARPOL are related to these greenhouse gases, to CO2 mainly. And these regulations in the chapters in the regulation 19/2021, on one hand for new vessels, they have to comply with this energy efficiency design index. And on the other hand, for all vessels, new and existing ships, they have to put in place on board of the ship this ship energy efficiency management plan. This is also a good try from IMO to try to reduce the CO2. And we'll see that with alternative fuels, we can have also reductions in that greenhouse gases. We have seen all these technical aspects, but now we are entering the commercial aspect of this LNG compared with bunker fuel prices nowadays. I have made the slide all in the same units, and the reason to put all in dollars per the BTU, thermal units, British thermal unit, is because the natural gas prices are not the same, are always depending on the energy content of the LNG. And the LNG is not the same if you buy the LNG in Norway or if you buy in Qatar or in Libya. So, but at the end of the day, what is really clear is that these are the levels in a spot market of the LNG all over the world. In USA it's very cheap because they are developing the shale gas, and these techniques are very cheap for the extraction of the gas. But in Europe it's very convenient, also the price. In Asia is a little bit more expensive, but compared with the marine diesel oil specifically, is very cheap. On top of the spot price, you have to take in consideration also the bunkering cost and the logistic cost. These are not prices of bunkering, and that prices are heavy fuel oil and marine diesel oil of the bunkering. But on top of that, you can put, let's say, $6, $7 more. You never know. But you are always cheaper than the marine diesel oil. You will be, in any case, much cheaper than the marine diesel oil, even in Asia. So LNG could be one solution. We'll see if there are others. How to comply with regulations? You can comply with different techniques, different solutions, different alternatives. You can modify the engines. You can have abatement technologies to reduce the content of NOx or SOx after the combustion in the engine. You can use different fuels, or even LNG or methanol or any other low flash point liquids. But I think when we are talking about solutions, I think it's easier to think, always to think in a solution upstream than downstream. I mean, if you have to solve a problem, you have to modify the content of fuel, of sulfur or SOx, NOx, of the gas emissions is more difficult than to put directly to put a fuel with a lower content of sulfur and lower content of NOx. And so we have alternatives, and we'll go through all of them. For the NOx, the best solution in the beginning, when we had this tier 2, is just to modify the engines, and we have a lot of solutions. To modify the engines means that the engine manufacturers try to reduce the combustion temperature in the chamber, and with the reduction of the temperature, you reduce the NOx in the emission, in the gas to the atmosphere. But this is not good for the tier 3, only for tier 2. And these solutions are not good also for efficiency of the engine and for the consumption. Normally the efficiency is worse than the original engine with tier 1. We have also water techniques, which means that we can use also emulsions of water with fuel and combine the techniques to inject water in the combustion chamber, or humid air motors, or scavenge air moisture for 2-stroke engines. Just techniques to reduce also the temperature in the chamber. These techniques are not in compliance with tier 3 also, and the same for the efficiency of the engine is not, the efficiency is reduced. Combined techniques with engine gas recycling or exhaust gas recycling and humid air motors are in compliance with tier 3, and there are some new regeneration exhaust gas recycling system for 2-stroke engines, which are in compliance with tier 3 also. But the only technique for the time being which can reduce the NOx levels to a tier 3 are the selective catalytic reductions. These techniques, by urea injections in this equipment, there is a catalytic reaction inside the equipment, so you have you reduce the content of the NOx in the gas, exhaust gas. This is a technique available in the market for practically all the engines, 4 strokes and 2 strokes. But you need these urea tanks, additional space, and another disadvantage is that these systems are normally designed for no more than 60,000 hours, so which means 7, 8 years probably for a new ship. You put the system, you have to renew in 7 years probably, or something like that. For sulfur regulation, for the compliance with the sulfur levels, we have the scrubber solutions. These exhaust gas cleaning systems are designed in order to reduce the sulfur content, the sulfur oxide content, and there are different kind of scrubbers. But we have almost a problem all the time, same problem with the space required for the scrubbers. There are big equipment. Also the weight, and you have to consider you have to put the scrubbers on the top of the funnel where the exhaust pipes are going, and it's very expensive also. But the most important about these scrubbers, exhaust gas cleaning systems, is that they have not been fully proven. There are few equipment suppliers. I think there are 6, more or less 6 all over the world. Most of them are seawater or freshwater scrubber or hybrid solutions. Freshwater scrubbers, for example, requires the caustic soda. The caustic soda is it's not a good solution for handling inside the ship. It's very dangerous also. And dry scrubbers have been used in the industry, in shore industry, but not in shipping. There is one company only developing this solution, but this solution also requires a lot of space, as you can see here, a lot of space for storing this calcium hydroxide and the lime granulates to store the produce after the cleaning of the exhaust gas, and there's a problem always with that. With the seawater scrubbers also you have problems with the water, the wash waters. You have to comply with the IMO resolutions regarding the pH content and the oil content, etc. So you cannot put the water that you have used in the scrubber directly to the water to the seawater unless they comply with these levels. So these techniques are really not 100 proven, fully proven for the reduction of SOx. So at the end of the day, we have to find different alternatives, or to use gas oil, or to use LNG or another fuel with less content of sulfur. In this chart, you have a kind of summary. I think it's just to repeat the same, but at the end of the day, these levels in the NOx, SOx, particulate matters, and CO2, you can reduce very easily with, for example, natural gas as fuel. And with the other techniques, we always find some problems or disadvantages. Natural gas, normally with these 4-stroke engines, we have 80 or more % of the NOx emissions reduced. With only gas engines, we have almost 90% of the reduction. The reduction in sulfur is clear because there is no sulfur in LNG normally, and particulate matters in close connection with the sulfur are close to zero. With the CO2, in principle, we can reduce up to 25%, but this is also depending on the methane slip. Methane slip is the methane which is not burned in the combustion chamber. If you have problems in the combustion chamber or because the engine is not well designed or things like this methane is going to the atmosphere, and the methane is almost 25 times more dangerous for the atmosphere than the CO2. So this is something we have to take in consideration. And the price we have seen already is competitive compared with the diesel oil. So all the industry has developed, IMO and the class societies in general, and we have developed a lot of regulations specifically for LNG as fuel on board of ships. From the beginning, in the gas carriers, we have used the LNG, the boil-off gas, as fuel for the LNG carriers. In the Ajax, we have also some examples. We have developed rules specifically for LNG as fuel. Bureau Veritas, we have particularly 2 regulations which help the shipping industry to design the vessels safely for LNG as fuel. In the IMO, we have these guidelines already in place since 2009, but there is just a guideline, there is no mandatory regulation, so they are now developing the IGF code, which will be mandatory. And now it's a little bit delayed, I will explain. The intent of the IGF code is to cover not only natural gas, but other gases and low flash point fuels like methanol, ethanol, etc. But there is a big discussion inside in the IMO subcommittee this year to try to develop the IGF as soon as possible, even if the methanol or other alternatives of fuel are not ready. There is one tent inside this group in the IMO asking to complete the natural gas regulations only, and then to add all regulations for methanol, etc. There is another trend asking to put all regulations, not only LNG, but methanol. And we'll see, but in fact, the problem is that the IGF is delayed, a little bit delayed compared with the original schedule. Since the beginning in Bureau Veritas, we have developed a lot of projects. I will show you some examples, but in gas as fuel for natural gas as fuel for gas carriers, LNG carriers, we have been the first to develop the dual fuel diesel engine LNG carriers. We start a joint project with Barcila and Chantier de l'Atlantique, Gaz de France, for 3 ships, and finally the shipyard delivered the ship in 2004 with dual fuel and diesel engine configuration. And later on, we also classified one vessel, the first with MAN, dual fuel, built in Korea. There are some more examples. I will pass a little bit faster. There are some examples also in the LPG vessels, using the ethylene sometimes, or the LNG for the consumption in the generators or in the main engines, already developed. And we have approved all the type of engines available in the market, 4 strokes with dual fuel, Barcila MAN, Rolls-Royce, only gas, and ABC now is almost complete, the type approval. Also for 2-stroke engines, we are in close cooperation with MAN and Barcila. MAN has almost finished the approval of the 2-stroke engines, high pressure, but Barcila is going to develop also the 2-stroke low pressure engine next year probably. There are some examples of gas fuel projects, and all shipyards, specifically in the Far East and here in Europe also, for sure. They are developing projects like ultra-large container ships, 14 TEU capacity, with 2-stroke engines, for example. There are some examples also with 4 strokes. We are having type approvals or approval in principle for projects like this in cooperation with CMA, CGM, and Daewoo in Korea. We have some examples here in Europe also for coastal navigation feeder ships using LNG tanks, portable LNG tanks, container tanks, and inland navigation tankers with different kind of solutions, Type C tanks, and emergency shutdown, protected engine rooms, separate engine rooms. All kind of solutions are available. and we are approving projects like this. This project is going to be materialized very soon. It's a project in Germany for the navigation, coastal navigation. And the gas, the LNG gas, will be stored in these trailers on board of the ship, of the ferry. And they have an hybrid system on board of the ship. So with the gas, they produce electricity and they store the electricity in batteries. We have also this experience with bunkering ships. We have developed approvals and we have checked drawings and specifications and designs for bunkering ships. These ships will have specific features, technical features. Specifically for these ships, you have to take in consideration the boil off in the tanks and the maneuvering of the ship and all bunkering facilities to be implemented in a safe way in order to avoid any problem with the transfer of the LNG for other ships. There are a lot of projects now. There is only one materialized in the world, but we are approving these drawings, these specific projects, and some of them will materialize very soon. This is an interesting project because this company is also a Sweden company. This company is developing with Bureau Veritas and in collaboration with some other companies, main engine suppliers, etc. This conversion. This is a chemical tanker and will be gas fuel, dual fuel, because it's expected to convert the main engine, the MAK engine, and probably also the Caterpillar auxiliary engines to burn LNG as fuel. With 2 tanks on board of the ship on the forward part. This is the solution that practically all the ship owners with these specific conversions are taking in mind, are having in mind, the Type C tanks on the deck. This is a project inside the Zero Vision tool here in Sweden and also developing inside the European Union funds arrangement. Another example for gas as fuel. This is a barge which is expected to be in operation in Hamburg. The intention of the barge is to use the LNG as fuel to generate electricity and to give the electricity to passenger ships on the port. It's a good solution because the ship owner is just buying the electricity, but they are switching off all the equipment on board, all the engines and generators on board. We have a lot of more examples of vessels already approved and designs for Aframax tankers, for container ships of any kind, with any kind of containment system. But that's not the end. That's not the end. What about methanol? So methanol can be used also, as you know, and there is one company developing a project with methanol here in Sweden. What is the only difference or the main difference with LNG? It's as simple as that methanol is liquid, it's a chemical, and the LNG is liquid, but it's a gas. So one has to follow the AGF, the gas, the AGF or the regulation for gas as fuel. Methanol is also following the AGF when the AGF will be ready, but it's a chemical, so you have to comply also with the chemical regulations. We have the advantage of the methanol is that it's liquid and for the storage on board and handling the liquids is easy or is more common than cryogenic gas. But on the other hand, it's very flammable, more flammable even more than the LNG. And it's toxic and they have some aspect in the viscosity, lubrication, which compared with LNG and other fuels is not a good solution, let's say. You see the methanol compared with the methane, with the LNG, Also related to calorific content, you can check the calorific content in the volume by cubic meter is also a little bit less than the methane. So it means that you have to put a bigger amount of methanol for the same production of energy on board of the ship, a little bit more. With the LNG you need double than the diesel oil, for example, because you have 21 in front of 40. But with methanol you even need more than double, a little bit more. This is the flammability content of the methanol, from 6% to 36% compared with this concentration only from 5 to 15. This means that if you are in concentration less than 5 or more than 15, the natural gas is not flammable. And with the methanol, if you are inside the 6 or 36% content in the atmosphere, in the air, then you have a flammable concentration, and this is difficult. ABC and AGF code must be considered for the methanol, and AGC and AGF for the gas as fuel, for the natural gas. With methanol, we have also good alternatives. Dimethyl ether, taken directly from methanol by the hydration process or by direct synthesis from the synthetic gas, With the dimethyl ether, we have the advantage that it's a gas, but with very low pressure to become liquid, only 5 to 6. So it's similar to LPG, for example, to liquefied petroleum gas. We can have the diesel cycle, so good fuel efficiency. The toxicity is very low. But on the other hand, we have very limited experience in ship. Now there are some projects, but it's really limited. This is the lower and high heating value of the dimethyl ether, so it's bigger also than the methanol, so there is another advantage in having an additional quantity of energy content on the liquid or the gas to be used. With methanol and dimethyl ether, I have seen some examples in the past. This was a very limited pilot project with really a fuel cell, not an engine to develop propulsion, just for electricity production, 20 kilowatts. But now, as you probably know, Stena is developing these projects with starting with one vessel, with this system of 8 on board alcohol to ether technology, and in the future probably with the other vessel with main engines, with Varsila, with an equivalent technology or similar technology. What are the weak points for methanol now? As you know, is the AGF, which is not finalized. And then, as the AGF is not finalized, it's almost finalized in the part of LNG, but not in the methanol, then all projects with methanol as fuel must have in mind the administration, the local administration for the approval, and the considerations in the SOLAS, because in principle in SOLAS the use of low flash point fuel is not permitted, but in some specific cases for cargo vessels, if the local administration approve the arrangement of with methanol or any other low flash point, you can have, for national trading, you can have these solutions. Different alternatives with methanol and dimethyl ether is very similar to the development on the LNG as fuel, because you can have the Otto cycle, which is the dual fuel concept, and you can have also the diesel cycle. But the diesel cycle is more efficient and is a good solution with dimethyl ether, with the O8 technology, for example, with this new technology. The efficiency is very good with this solution, dimethyl ether in the diesel cycle, and also because with this solution you can comply with NOx by using the dimethyl ether in substitution of the urea. This is something very interesting because the fuel can be also used in a catalytic reaction on board of the ship to reduce the NOx and then to comply in a diesel cycle with the NOx, not only with SOx but NOx. This obey technology that is now implemented and is being tested, or is going to be tested in this Stina, for example, vessel. This is not exactly this solution because this is a diagram taken from a MAN document, but it's just to explain that the system is easy because you are storing the methanol in liquid form because it's liquid, it's a chemical, ethanol or methanol, but okay. And then, by a catalytic reaction, you have a mix between alcohol, water, ether. So this mix is stored in a tank, O8, on board alcohol to ether. And this is really the fuel that you are going to use on board the ship to produce the power for propulsion or for electricity. What is the advantage of this O8 technology? Well, I think there are two advantages. One, that you store in liquid form the fuel, is not cryogenic. And secondly, as you have a mix with water also, you reduce the content, you reduce the combustion temperature in the chamber with this hot mixture, with this mixture of water with alcohol, ether. You can also comply with the NOx levels. So, what is the future? Well, we have seen that LNG is all over the world. All people thinking, all ports are developing the LNG terminals, small-scale terminals, bunkering ships. The logistics will be probably in place for the future. For this deadline, we have the 1st of January 2015. This is worldwide, because we have seen in Europe, Rotterdam, Gothenburg, Hamburg, Antwerp, many ports all over Europe, and also in the United States, Singapore. They have also decided to go to LNG as fuel. They will go to LNG as fuel. With methanol, we have a solution, but this solution is a little bit delayed compared with LNG for the time being. But it's not bad. Technically, it can work. So that's all for my presentation. Thank you very much for your attention.
Yeah, thank you so far. Take your chance when we're expert here, and if you have any questions, please feel free.
Well, this fuel tank, these silica zones, how were they determined and decided?
The Seca zone, sorry?
The Seca zones, you know.
Yes.
Do you have
Sulfur, yeah.
Yeah, the sulfur emission zones. How were they decided that it should be the Seca zones as it is?
How they have decided?
Have you any?
How?
Yeah.
The IMO. Well,
yeah.
Yeah, well, in the beginning, I think when they developed the MARPOL Annex 6, when they started to develop the air emission pollution regulations, they also define the way or the process, the steps to be done to become emission control area. And those days, some organizations inside the IMO or parallel send proposals to IMO for the definition of emission control areas. Nowadays, there is one, for example, let's say, association or commission in Helsinki, the Helsinki Commission, I understand. Now is trying to develop NOx area also in the North Sea and Baltic. It's trying to ask IMO to define or to make North Sea and Baltic Sea also for NOx, not only for SOx. With this last committee, environmental committee in March this year, as they have agreed this draft to delay 5 years the effectiveness of the tier 3, probably this committee also will wait a little bit to ask for that. But at that time, I think was a similar situation. There were administrations, there were companies involved in this kind of associations, but inside the IMO, and they make the steps, necessary steps to ask for the definition of specific zones. And you have a procedure in one annex of in one appendix of the IMO, Annex 6 in the Appendix 3, I think. You have the regulations or the specific procedures to ask for one specific area. There are some. Singapore now is talking about one specific area, and they are talking about Japan also, Hong Kong, Mediterranean, Australia. There are many things.
Thank you.
The Viking Grace, the energy shift in Stockholm is a big success.
Yeah.
But what about the fuel line shift that now has been stopped to bunkering in Norway? Have you heard anything about that? That's something that will...
I have heard that there is one cruise vessel. Yeah, you mean this cruise vessel? I have heard a lot about the Viking Grace, because the Viking Grace is in service since December, January.
Yeah.
I heard that in the beginning they make it bunkering with just with trucks, which was not efficient at all, and probably Stockholm Port Authority was not satisfied with this bunkering process, and they have developed one small bunkering ship. In fact, it's a conversion, it's just a barge with 200, something like that, 200 cubic meters on top of the barge, LNG. But about the cruise vessel, I have heard that the vessel is delivered, but since July or something like that.
And they cannot bunker the ship in Norway.
Why?
Because the authorities says no. They're not allowed to bunker it with passengers on board.
Yeah, this is a difficult question. Yeah, well, a difficult question, I mean a difficult thing, because bunkering procedures nowadays depends on the port authorities, in fact. And there are some port authorities trying to develop specific regulations for LNG bunkering. If the port of Oslo or another port is not approving the LNG bunkering, when the crew is on board and when the people is on board, or just leaving the boat or entering the boat or this kind of thing, in parallel, this is something the port authority must authorize, yes? So
you're saying there are not common rules for this?
no.
It's done by case studies?
For the time being, yes.
It's a risky business, huh?
It's risky, but the thing is that all ports, major ports in Europe, are developing rules for that, for bunkering. Rotterdam is just an example, but Hamburg is developing an LNG terminal. Gothenburg is also thinking on LNG as fuel. I personally think that we have several alternatives of fuels, but people in general is more interested in LNG. And I think this is because distribution probably is a worldwide distribution. There is plenty of LNG. There are facilities, terminals, import, export terminals all over the world. I think this is my feeling, but at the end, why methanol is not becoming really interesting for France, for example? Well, probably because the methanol production in France is lower than LNG traffic. Yes, I think always behind the technical question, there are economical questions. Always behind. Interest is the only...
Celia, back to the price issue. You compared heavy fuel with the price of the LNG. How is
This is the bunkering, real bunkering prices taken from the internet. In fact, Bunker World 2 weeks ago, something like that. But these are just spot prices. These prices are not really bunkering, LNG bunkering prices. Why? Because you cannot find.
There is no index.
No. For the time being, you have to deal directly with the gas companies to ask for that. And some passenger ship companies, for example, has already dealt with gas companies and has agreed and one price for that. And then these companies know really in Europe if the price will be 16, 14, 17, and then you compare with that.
But the natural gas prices that you have in the chart to the right, is that in liquefied form, LNG, or is it natural gas?
Natural gas,
So there is a additional
transportation,
yeah, and the
liquefaction, transportation, yeah.
10% energy loss. In
Yeah.
And this,
No, yes but no. When you are buying in Asia, for example, LNG, you have prices around $15. So the difference is not too much. Huh? Now,
makes sense, but
yeah. Now the importers,
I didn't know
yeah.
whether it was included or not.
In some way it's included here, in some way. But did you find prices for importing to Japan, for example? Nowadays, you find prices around this. A little bit more probably, 15, no more than 15. But if you see in Europe the price, also importing price of LNG, and you put all the logistics, etc., at the end, the price will be more than probably more than the fuel, for example. Yeah, that's right, probably, but less than the marine diesel oil. Less up to the point of 16, 20. 20 is becoming very interesting, even if the price finally is $20 per BTU.
Yeah, Dank Obama from Bama Shipyards. What this person in front said is quite important, regulations for bunkering operations in ports. And you tell me that the ports are now thinking about the rules. Will there be any cohesion between those rules, and is there a regulated body that is trying to organize that a bit?
But I think some ports are developing rules in cooperation also with another entities. So we will have the standards for bunkering. For example, in the ISO, this ISO working group has already finished one document, one standardization document for bunkering. But this is not the end of the regulation. This is just a standardization document, ISO document. But then, from the safety point of view, these ports have to approve the operation, the bunkering operation. But I don't think there will be a conflict. Will be a conflict, it depends. If each port has different regulations, will be difficult to comply. Yeah, I got your point. I understand your point that
Maybe I can put something more on this one, because it's not a standardization paper, it's a technical report. And it's publicly accessible today, and I think actually it's public today. It is recommending that everyone that does or thinks about doing a bunkering procedure with LNG has to do a risk assessment on the place and where you are. There's some rules that coming up that they say, you're gonna have that this year, you're gonna have that, so on. And then they go down and tell you that every time you do the operation on a new place, you have to do a risk assessment. Because you have to look out for everything else around you, not only that. And that's the problem when we assess, they recover mines. They're not really satisfied with risk assessments.
In your view, how many vessels will we have globally of burning LNG as a bunkering when we come to like 15, 16?
Now I think there are around 40 probably already delivered since the beginning, was 2001, 2002. Now we have 40, but it depends. I think this solution, LNG as fuel, probably for a new build nowadays, for a vessel which is almost all the time in a SECA area, I think is the best solution now for a new build. I mean, if you have to convert the vessel or to put a scrubber or to decide what to do, and the vessel is at the end of the life, then you probably decide just to switch to gas oil. So at the end, I think it's difficult to predict. Some people say there will be 600 in the next 10 years. Some others say 1,000. I don't see 1,000, but I see probably a figure in between. If we have now 40 and another probably 40 under construction, and then following this trend, you can have 400, 500 in the next 10 years. It's difficult.
What about bunker boats?
Bunker,
LNG bunker boats.
bunkering tankers.
Yes.
Well, we know that there are some projects, but there is only one already signed in China. The vessel will be delivered next year or maybe 2015. This will be probably the first, unless some other enter and decided to build another and very quick. But here in Europe, there are now at that time you have examples of vessels which are able to develop bunkering operations. This vessel is just an example. This is an LNG carrier, multi-purpose gas carrier, but this vessel has already done transfers, LNG transfers to bigger and smaller vessels here in the Baltic. So this vessel, one day they decide to cancel, or just because they finished the charter agreement with Scangas or with another company, and then they decided to go to the port of Rotterdam because the owner is a Dutch owner, and they decided to make bunkering. They can do it with this vessel. But now we know that there are, let's say, several projects here in Europe for building new bunkering ships in the range of 5,000–6,000 cubic meters. And this vessel is in this size also, in this capacity. So we will need in any case, because the bunkering ships will be needed at some point when the storage capacity on board of the gas fuel ship is more than, let's say, 200, 400 cubic meters. You will need 10 trucks to fill the LNG. With 400 cubic meters, you need 10. And it's not efficient at all. So you will need an LNG bunkering tanker. In the next years, I think we will see at least 2–3 more.
So
New buildings. A part of that one, because
That is the suspicion ocean.
That's
That's a spit in the ocean. 2, 3 bunkables. It's nothing. Huh?
we will see. I think all people is really waiting the moment to take a decision.
Yeah, because
If they feel-
the LNG, Guerrero, the METHANOL, I mean, it has to be some, I think some body has to take.
Yeah. But in any case, in the European community, I think they are supporting really the LNG as fuel. Huh? They have a lot of plans, and they are supporting the different projects, even for inland navigation. There is one project in the Danube, the Rhine and Danube rivers. Another project with Gothenburg and Rotterdam involved, another project with French ports. There are many people in the European community with, it seems that the interest to develop LNG is very, very high.
But it seems the interest all comes from somebody that wants to sell to the but the interest doesn't come from the ship owners who is actually going to burn the energy. It's like a lot, as you said, there's a lot about LNG providers, people like yourself or equipment manufacturers, they will all like to sell that one because it's a new adventure.
Yeah.
But there's kind of nobody on the buying side.
I can comment a little bit on it. My name is Becky Lietmans. I'm from Vopak Energy, and we're trying to develop the terminal in Gothenburg. The thing is that most of the oil majors who also produce LNG, like Shell and the Shells and etc. As well, they currently have, and I think that will last for a while, have a very good market at very high prices in Asia. So they are not pushing it from that because the revenues will be lower for the Northwest European market. But you have the shipping costs to go to Asia, they are the differential. So if you can have the LNG from, say, the Middle East, from the Mediterranean part, the shipping distance to Europe is much shorter than to Japan, where a lot of LNG is currently going. So I think it's a little bit, I don't think it's the truth that they are pushing kind of the LNG into this market and there is no demand from ship owners, because I've talked to many ship owners and there is a demand for LNG, they would like to switch to LNG, but they're not sure whether there will be supply, they're not sure whether there will be the infrastructure to have the LNG. And the thing is that everybody seems to be waiting for each other and somebody to take the first step.
Yeah.
So, and we in a joint venture with Sweetgas and Vopak and with in cooperation with the Port of Gothenburg, we are looking to take the first step, but it's still big investments.
Yeah.
And I think over the whole chain, if we want to make it work, that needs that the whole chain should be willing to take its risks to go and convert to LNG. And so I think in the end it will come, but it can take very, very long time if nobody takes the decision to step into
LNG.
the next first step.
I think, for example, in the USA, we have seen that they are also really interested to enter into LNG as fuel. And we have seen that they are thinking in even in big ships, not like here in the Baltic, for example, with small ferries, now bigger ferries, like the Viking Rail, but not before. But in the United States, they are thinking about container ships, 3,000 TEU container ships with LNG as fuel.
Also
And
oil tankers with
yeah.
2,000 cubic meters tanks on board.
But I think for the owner it's difficult to take a decision. At the end it depends on how old is the ship, if they make the conversion, or if they want to just to renew the fleet and to scrap the vessel and to build a new one. It's a big and difficult decision from the economical point of view. But because we know that LNG conversion and LNG facilities on board of the ship is not a cheap solution. We know that it's not cheap, but can be cheaper in long term than another solution.
I understood that prices already have gone down for
Yeah.
the differential from a dual fuel ship compared to
Exactly.
conventional.
Yeah.
So it used to be more expensive already, so it has gone down.
Yeah, it's almost the same in the beginning when you have a new technology, and the prices in the beginning are very expensive. When you buy an hybrid car now, it's less expensive than 3 years ago. That's, but also the community must be comfortable and confident with the solution, because if they don't find the facilities or they don't find where to bunker, this is why the European community is supporting these plans for developing the LNG bunkering, just to help also the ship owners to help them to try to decide.
Yeah, Carlos, thank you very much what you have shared with us this afternoon. It's very
My
interesting.
pleasure.
And also a very interesting discussion after all. So thank you very much.
Thank you.